Hi, we are now on lesson 4 or week 4, quadrilaterals. The video that you will see will illustrate how to solve worded problems. Here is example number 1. A rhombus has diagonals of 32 and 20 inches. Find the angle opposite the longer diagonals. Also, determine its area. A rhombus is a parallelogram in which all sides are equal. It may also be called as an equilateral parallelogram. The diagonals of the rhombus are also given as 32 inches and 20 inches. We are being asked to find the angle opposite the longer diagonal, which is theta sub 2, and also its area. The formula to find the angle opposite the longer side is theta sub 2 is equivalent to 2 inverse tangent the quantity d sub 2 over d sub 1. Substituting all the given in the above formula yields 2 theta sub 2 is equivalent to 2 inverse tangent the longer diagonal divided by the shorter diagonal. Thus, theta sub 2 is equivalent to 115.99 degrees. Likewise, we can compute for the area of the rhombus as the area of the rhombus is equivalent to 1/2 shorter diagonal and the longer diagonal. Substituting all the given in the equation for the area of a rhombus, we have area is equivalent to 1/2 20 multiplied to 32, thus giving us an area of 320 inch squared. Let us now proceed with example number 2. A rectangle and a square have the same area. If the length of the side of the square is 6 units and the longest side of the rectangle is 5 more than the measure of the shorter side, find the dimensions of the rectangle. In example number 2, we are given two polygons, which are the rectangle and the square. The rectangle and the square have the same area. The length of the side of the square is 6 units. This is the reason why we can find the area of the square immediately by substituting it in the formula for a square, which is the area for a square is equivalent to side squared. Area of a square is equivalent to 6 squared, giving us the area of a square is equivalent to 36 units. The area of the rectangle is given as length multiplied to the width. Since in the given problem, the longest side of the rectangle is 5 more than the measure of the shorter side, we represent the shorter side as x. Thus, the longest side will be 5 plus x. We are being asked to find the dimensions of the rectangle, which are the length and the width. The formula that we will use is the formula for the area of a rectangle, which is the area of a rectangle is equivalent to length multiplied to the width. Since the length is represented as 5 plus x and the width is represented as x, then substituting it in the area of a rectangle formula, we get this quantity. Since the area of a square is equivalent to the area of the rectangle, which we computed earlier as 36 units squared, we can substitute 36 units squared as the area of the rectangle, thus giving us the working formula of 36 is equivalent to 5x plus x squared. And rearranging the quadratic equation, we have x squared plus 5x minus 36 is equivalent to 0. We are now faced with a quadratic equation which can be solved by factoring. Thus, we have the quantity x plus 9 and the quantity x minus 4 is equivalent to 0. Solving for x in the first factor gives us a negative 9, which we are going to reject because there is no negative length. The second factor is x minus 4 is equivalent to 0, which gives us x is equivalent to 4, which we will accept because the unit 4 units is logical for a unit of length. Finding the length, which has an equation of 5 plus x, substituting x as 4, we have 5 plus 4 is equivalent to 9 as the length of the rectangle. For the width of the rectangle, which is represented as x, is equivalent to 4 units. Therefore, the dimensions of the rectangle is the length is 9 units and the width is 4 units. Let us proceed with example 4 under quadrilaterals. The area of an isosceles trapezoid is 246 meters squared. If the height and the length of one of its congruent sides measures 6 meters and 10 meters respectively, find the two bases. In example number 3, we're given an isosceles trapezoid. An isosceles trapezoid is a quadrilateral with one pair of parallel sides. The area of the trapezoid is given as 246 meters squared. The height and the length of one of its congruent sides measures 6 meters for the height and 10 meters for the length. Since it is an isosceles trapezoid, the other congruent side is also 10 meters. We are being asked for the length of the two bases, A and B, the two bases. The formula that we will use is the formula for the area of a trapezoid, which is area is equivalent to 1/2 the quantity A plus B multiplied to the height. Using Pythagorean theorem, which is c squared is equivalent to a squared plus b squared, we can get the length of the base formed by one of the congruent sides and the height which is indicated in the figure. Solving for the length of the base yields 8 meters. Since area has the formula of 1/2 A plus B is equivalent to H, the height, the area gives us the area is equivalent to 1/2 the quantity 2A plus 16 multiplied to the height. Solving for 2A gives us 2 multiplied to 246 divided by 6 minus 16. Therefore, A is equivalent to 33 meters. This is the length of the shorter base, which is represented as B1. The length of the longer base is B is equivalent to A plus 16. Since A is equivalent to 33 meters plus 16 will give us B is equivalent to 49 meters. This is the length of the longer base. Therefore, the two bases measures 33 meters and 49 meters. Thank you.